Hello friends. Um, in this video we will learn about the pointers in C++. So most of the concepts are similar to C, so this can be used in C as well as C++. Okay, so let's begin. So what is a pointer? So all of you um, basically knows that when we create a variable of particular type, just like integer or float or double, that variable holds the value of that particular type. Okay, so pointer is nothing but a variable but that holds the address of another variable. In simple terms, pointer is a variable that holds address of another variable. Okay, how do we define pointers in C++? So pointers are declared or defined similar to the variable, just that we add a star uh, operator along with the type of the variable. Okay, so as you can see, a variable of type t star can hold the address of object of type t. It simply means that, let's understand it with the example. So I have created one variable of type char named c, which holds one character. Now how to create a pointer. So pointer is created using character star. Okay, so char star p equal to ampersand c. Now what is this? So here c is a normal variable of type char which holds one character a. P is a pointer. Okay, now when I say pointer, pointer always holds the address of some object. Okay, so P is a pointer and type of the P pointer is char. Okay, so we can read it from right to left. So P is a pointer of type char which holds the which can hold the address of any character variable. So that's what here I have made. So P here is basically holding the address of character C. Okay, yeah, now both C and P refers to the same value A. It's just that C holds the value, but P holds the address of C. So indirectly, P also refers to the value A only. Okay. So in the diagram, you can see that here somewhere in the memory, system memory, C is declared and C holds the value A. Okay. Now somewhere in the memory, P is also defined, but P holds? P holds ampersand C. That is, P holds the address of the memory location where C is stored. Okay, so C holds the value, but P holds the address of C. Okay, now what are the major fundamental operations of on pointer? Why do we use pointer? So there are various use cases of pointer, but the most simple and most useful operation on pointer is dereferencing or indirection. So what is dereferencing? Now I have created the pointer P which holds the address of C. If I want to know that what is the value that P holds, what is the actual value that the P holds, so we basically perform this using star P. So star P, the star operator is called as dereferencing operator or indirection operation. Okay, so here third line I have declared variable C2 which contains star P. So when I say star P, what it does? So now P refers to an ampersand C. So star C, what it does? It goes to this memory location where C is defined and finds out the value A. Okay, so star P will have A. Okay, P contains the address, but star P will actually contain the value. Will give us the value of the address which P is referring to. Okay, so C2 will contain A here. Okay. Now, since pointer basically actually works with the addresses and memory location, it is a very, I mean, it directly associates with the how system creates memory, like number of bytes. So when we say a data type needs some number of bytes in the memory. Okay, so integer needs 4 bytes, double or float needs 8 bytes. Okay, character needs 1 byte. Okay, so the smallest object that can be allocated and pointed to by a built-in pointer is of type char, because there is no data type which can be allocated with less than 1 byte. Okay, so character needs 1 byte, so the minimum object or minimum variable which can be allocated and pointed to by pointer is char. Okay, boolean is also there, but boolean also needs the same size as char. Okay, now let's understand like how to use pointers with arrays. Okay, so when we create array, what we do, we create a size number of element. We create array like this, like I have created an array v here. okay, which contains 4 elements. I have not specified the size of v because in this case size of the array is identified by system itself by looking at number of elements it contains. So size of v is 4 and v is an array. Okay, now it is very special case for pointers, how to use pointers with arrays. So listen this line carefully. So name of the array always refers to the first element of the array. Okay, so name of the, so indirectly name of the array, any kind of array acts as a pointer to that array. Okay, in C and C++, name of the array acts as a pointer to that array. Okay, so here if you see, I have created a pointer p1 and I have assigned v. Okay, so here it's not like the entire array v is getting copied into p1. Okay, v is an array, but when I use the name of the v, it is implicitly converted to the pointer of type int. Okay, that's what here it's happening. And this v will now point to the first element of the array, that is v is a pointer which points to the first element of the array. Okay, so I have assigned p1 to v. So um, since v has been implicitly converted to the pointer, p1 will refer to the first element of the array, that is 1. Okay, so here now let's consider the second line, that is star p2. I am creating a pointer p2 and assigning it the address of ampersand, basically gives us the address of a particular variable or object. So ampersand v0. So what I'm doing, p2 pointer will contain address of 0th element of v. Okay, which is also again the initial element because pointer starts from 0. So in this case p1 and p2 both refers to the same initial elements, just like create, it just differs in the way we create pointers from the array. Okay, so in the right hand side you can see in the diagram that p1 and p2 both refers to the address of the initial element, that is the one element. Okay, first element of the array. Okay, similarly I have created a pointer p3 which contains the address of the third element of the array. Okay, so right hand side you can see that pointer p3 will hold the address of 0 1 2 3, third element, which contains value 4, but element number is third. So p3 will contain the address of third element of the array v. Okay, the most important point here is name of the pointer acts as the pointer, name of the array acts as a pointer to that particular array. Okay, now when we create a pointer to the array, various arithmetic operations like plus minus, plus plus and minus minus can be applied to the pointers. Okay, so like we can increment pointer, we can decrement pointer when we, so when I, let's say when I have assigned v to the p1 pointer, if I do p1 plus plus. Okay, so currently p1 points to the initial element. When I do plus plus, p1 will point to the next element of this array. Okay, if I do p1 minus minus, so it will refer to the earlier element of the array. Just like that we can perform arithmetic operations on the pointers too. Let's consider an example. In the below I have uh, created an array of int v1 which contains 10 element, array v2 which contains 10 element. Now if you see what I'm doing in the third element, I am basically finding the address of fifth element of the array v1, and I'm doing minus address of third element of the same array. Okay, so when we perform subtraction, okay, so arrays can be subtracted. So when we perform subtraction on the array, the result is always the number of elements between the number of elements between those two basically addresses. Okay, so between the address v15 and between the address of v13, same element, how many elements will be there of int type? So 5 minus 3 2. So the result of this subtraction of the pointer is always the number of element of the uh, type of the pointer. So v1 is a v1's type is int, so this subtraction will give us the int result, and result will be number of elements between these two addresses. Okay, so I1 will contain 2 here. Okay, so whenever you want to perform any addition or subtraction with the pointer should always uh, pointer to the array, the pointer um, sorry, whenever you want to perform addition or subtraction of the pointer which is pointing to the array, uh, both the pointers should always point to the same array. Okay, pointing to the different array will not work. It will give us undefined behavior and compiler may complain, okay, while running the program. So you can see that here int I2, basically what operation I'm doing for int I2, I am subtracting the address of v2's third element from the v1's fifth element. So both of these arrays are pointing to the different array. Both of these, basically v1 and v2, are pointing to different arrays. This operation cannot be performed, okay, so this will result into undefined. Always whatever point arithmetic we are doing on the uh, array pointers, those must point to the same array, okay. Similarly, plus minus can be performed on the pointer, as we have seen that name of the array acts as a pointer to the array. So here I have created a p1 pointer which contains v2 plus 2. So v2, when I'm using v2, it will, so v2 array, v2 will refer to the first element of the array v2. When I'm doing plus 2, so it will basically incrementing the pointer by 2. Now p1 will contain the address of v2's second element, okay, as you can see in the comment, p1 will contain address of v2's second element, okay. Similarly, p2, we can subtract any number from the uh, uh, pointer, okay. So when we perform addition and subtraction from the pointer, the result is always pointer, okay. I repeat, when we perform addition or subtraction with the pointer, the result is always pointer. So here v2 is acting as a pointer to the array, and okay, because name of the array always acts as a point from through the implicit conversion, it converted into the pointer, okay. So now here the, for the case of p2, p2 is undefined because v2 points to the initial element of the array, and there is no element before the initial element. I mean, there is no array element before the zeroth element, so it will result into undefined, okay. So this is about pointers and array. I hope you must have understood. It's very interesting. This, you can perform all these operations in your code editor and see the results, okay. Now we will see the pointer and constant, okay. Just like we can create a constant variable, we can also create constant pointer, okay. How do we create constant pointer? We use the same keyword as const to make the pointer constant. Now uh, it's very interesting. So when we create a pointer, we actually are dealing with two objects, okay. One is the pointer itself and another is the object to which the pointer is pointing, okay. So in our previous case, so when I created p1 with v, so here we are dealing with two objects, p1 and v, okay. So there are two things. We can either create a constant pointer or we can create a pointer to the constant object. Okay. What is the difference between pointer to the constant object and constant pointer? We will see through this example. So just basically note that we can create a constant pointer using the star const declarator. Okay. So consider this example. I have created an array of type char, okay, which contain this string code developer. Okay. Now I have created a pointer p, which is pointing to the s. Okay. So when we use name of the array, it implicit conversion, it converted to the pointer. So p now points to the first element of this array s, that is c. Okay. Now in the third line, what I'm doing, I'm creating a pointer to the constant object and not a constant pointer. Okay, what is the difference? We will see. So what is the declaration? Constant char star pc equal to s. Okay, so this, what is this? This is a pointer to constant. What is pointer to constant? That is, if I want to change the value of sum of the character of s using this pointer pc, I will not be able to do. Okay, now here pc refers to the s. Okay, now if we do pc3 equal to g, that is I want to change um, this e character to the g, we will not be able to do that. Why? Because this is a pointer, it is pointing to the constant character. Okay, constant character it is pointing to, so we cannot change the object, but pc can be changed. The pc pointer, we can now assign it to the p. Okay, this is okay. Why? Because in this line constant char star pc equal to s, what we are creating, we are creating a pointer to the constant character. and we are not getting a constant pointer to the character. So there is a difference. When we create a pointer to the constant object, we cannot change the object which the pointer is pointing to, but we can change the pointer. Okay, because pointer is not constant, but the object which this pointer pointing to is constant. Okay, now how do we create a constant pointer? So just change this notation. Just look at the difference here. At this line we are creating a constant pointer, okay, to the character. So I am creating a CP as a constant pointer that refers to the S, again to the same character, this code developer character array. Okay, so this is a constant pointer. Here, if I want to change the value of third, basically character, that is value to a, I am able to do that. Previously we were not able to do that, but now we are able to do this change, because here the pointer CP is a constant pointer to the object. It is not a pointer to the constant object, but a constant pointer to the object. Here the pointer is constant, but the object is pointing to is not. That's why we can change the value of the object it is pointing to, but we will not be able to change the pointer itself. So here CP equal to P I cannot perform, because this pointer is a constant pointer, and we cannot change the value of the constant pointer. So how do we create both constant object as well as the constant pointer? So combine this both, the concept. And so if you see the third example, I have created CPC as a pointer, constant char star const CPC equal to S. So here what we are doing, we are creating a constant pointer to the constant object. Here pointer is also constant, and the object it is pointing to is also constant. So here if you see, we cannot change the object it is pointing to, as well as we cannot change the pointer itself. So both the things we cannot change. Okay, so that's how we create a constant pointer to the constant object. So the simplest way to read this type of notation is to read from right to left. Okay, so if you consider first example, what is PC is a pointer to character constant. Okay, pointer to character constant. If you read second example, here CP is a constant pointer to character. Okay, that way it is easier to understand. And last example, CPC is a constant pointer to character constant. Okay, yeah, that's how we create a constant pointer. Okay, last concept for today's topic, pointer to void. So we can also have a void pointer. So what is void? S- Void is basically none or nothing. Okay, whenever we want to create a pointer, um, so basically this void pointer is mostly used in function calls and a return type. Okay, so what is void pointer? So void pointer can point to any type of variable. Okay, like it can point to int, float, double, anything. So void pointer can contain address of any type of variable. That is the use one of the use case. um, I mean, we can assign the address of any object or any variable to the void pointer. Okay, but we cannot use void pointer. I mean, we cannot perform the plus plus, minus minus, plus minus on the void pointer, because as the name suggests, void, it doesn't. So basically, system or compiler cannot identify the size of the object which this void pointer pointing to. So we cannot perform any arithmetic operation on the void pointer. If we want to perform any operation on the void pointer, we will have to convert it into that specific type. Okay, let's consider as example. Here I have created a variable p which contains the value 10, of type integer. I am creating a pointer pi which contains the address of this variable p. Okay, I have created another void pointer PV, which basically refers to the same pointer. Okay, so what I have said, that void pointer can refer to any type of pointer. So PI is an integer pointer, and but PV is a void pointer, so it can refer to any type of pointer. So here PV refers to this PI pointer. Okay, both this contains the same address. Okay, uh, how it happens, because we can this is a system defined, so that any type of pointer can be assigned to void pointer. So through the implicit conversion, this pi's int star is converted to the void star. Okay, we internally it is converted to the void star, and that's how we can assign pi to pv. Now since pv is a void pointer, we cannot do star pv, that is we cannot dereference the void pointer, because it's a void pointer. The system doesn't allow dereferencing void pointer, because size of this particular pointer is size of the object pointed to by this void pointer is not known to the system. Okay, we even cannot perform plus plus, because in order to perform plus plus, system needs to increment the memory location, but void doesn't specify any, doesn't basically reflect or doesn't contain information of what type of object the void pointer is pointing to, so when we cannot perform arithmetic operations. Okay, we cannot increment void star, because the size of the object pointed to by pv is unknown. Okay, because it's a void pointer. The last line basically for this video, so void pointer should not be used unless it is very much required. Okay, so whenever we use void pointer, that means we there is some flaw in the design and it should not be used. Okay, so that's all we learn. Pointer in cpp, pointer to array, pointer to constant, and pointer to void. Let's look at one of the example I have created for you all. Okay, so here I have one function which takes character pointer as input. Okay, and I'm iterating that, uh, that basically uh, the character point, I'm basically printing that string pointed by this character pointer using the pointer arithmetic. So if you see, this function takes the character pointer as input. Okay, so which can this pointer can contain the address of the array of type char. Okay, and in the for loop, uh, so you might know that each character string is terminated by null character in cpp. So what I'm doing, I'm iterating this character pointer till I get the null pointer. Okay, and I increment this pointer, and I'm printing the character pointed to by the current pointer uh, location. Okay, how? Using this dereferencing operator star. Okay, so in the main, I have created this character string code developer. Okay, I'm printing the size of a. The size of a will give me the size of all the characters of this particular string. I'm passing this character string to this particular print function. Now through the implicit conversion, this name of the array is converted to the pointer. Okay, and here through the pointer arithmetic, like plus, I'm working through the plus plus. I'm After printing each character at the current location, I'm doing plus plus, that will increment the pointer to the next character, and through dereferencing operator, I'm printing the character. Okay, in the second example, this a2 is a pointer, character pointer, which points to a plus 2. Okay, so a is acting as a through implicit conversion pointer to character string. This plus 2 means uh, from the start second character, so 0 1 and 2. So a2 will contain the address of this d character. Okay, and when we basically print this a2 through star a2, it will contain d as a character. Okay, third example, uh, here the integer, I have created one variable called b which contains the value 10, created one pointer which contains the address of this type b. Okay, and if I print this p, this will give me the address of b, because pointer contains the address. Now let's look at in the output. P does not name a type. Okay, so this line has given us the size of the array as 14, because there are 14 characters. I have passed this a to uh, print. Print is also printing the size of a. Now previously in the main, when we use the size of a, it give me the size of all the characters. Now in this function, when I use size of operator, it's giving me the size of the pointer. So on this machine, the pointer size is 8 bytes. Okay, um, okay, so any pointer when we use, its size is 8 bytes. Okay, the because I think this is a 64-bit machine, that's why it is an 8 byte. Okay, and in the for loop, we have printed this character string, so this code developer is printed. Okay, then again in the main, we refer a2 to the second character of this, I mean the character at index 2 of this character string, which is printed. So d is printed here with this line. Now when we are printing the address of this pointer, if you see, we are printing the address in hex notation. Okay, by default system prints the pointer value or the address in the hex notation. Okay, yeah, that's all for the pointers in C and C++. Okay, thank you.